Okay, students, we're going to talk about dilations of lines and points. This is mod 4. Okay, so mod 4 is all about lines. Okay, lines, line segments, systems of lines, graphing inequalities. Okay, some of that you've done in Algebra 1. Okay, so this is going to have the most relevance from your Algebra 1 material when you deal with lines and shading. But there'll be other things to add to it, and this will also dealing with lines will be used in Algebra 2. So you need to make sure you know this and get this down, especially when you deal with lines themselves. All right, so dilations. Uh, First thing, if you have a line segment and it's dilated by a factor of whatever amount in that line segment itself. So if I have this line segment right here and a dilation or a point that's being dilated is on the segment itself. Let's just say this line segment, well, we could 1, 2, 3, 1, 2, 3, 4. So that's a 3, 4, 5. So it is 5. Pythagorean triple right there. So that line segment is 5 and say length of 5. Let's say it says it's dilated by a factor of 2. Anytime the center is on the segment itself, all you do is multiply by whatever that dilation is, and that's new. So it says dilation of 2. Capital D stands for dilation in function notation. So that'd be dilate this by a factor of 2, centered on any point on this line. It means just double that line, so it becomes a length of 10. Okay, the dilation of 3 would be a length of 15. Okay, just so you know that. All right, next, let's say they give me 2 line segments. I'll go like this, and um, let's do one like that. Okay. Now remember, how do I find the center of dilation? I need to go ahead and connect need 2 corresponding points. I go through, draw a line segment there. Okay, so it goes through those 2 corresponding points, and I pick another 2 corresponding points that it must go through. Okay, and let's put that, make sure you see it right there on that corner right there. Okay, so that tells me the center of dilation is right there. We'll change the color so it stands out. Remember, that's how I get my center of dilation. I take two corresponding points and draw a line through it, and another 2 corresponding points, draw a line through it, and where they intersect, that's my center of dilation. Okay, now if it goes ahead and asks you what the scale factor is, okay, there are a couple ways of doing that. I can either, and so we'll call this one, we'll put A, B, and that's A prime, B prime. Okay, so we see it got longer, so that's called an enlargement. Remember, when it's greater than 1, the scale factor is greater than 1, that's an enlargement. And if it's between 0 and 1, really between, technically it's absolute value of 1. Because remember, we talked about if it's a negative, that means it goes through the center of dilation, it goes to the other side of the center of dilation. And so this really is between -1 and 1. Again, because if it's negative, it goes through the center of dilation, that same amount on the other side. If it's positive, it stays on the same side. So since this pre-image and image are on the same side of the center of dilation, it's a positive number. So it's not negative, it's positive. So therefore, since it got larger, it's going to be greater than 1. Remember, if it's between -1 and 1, that's called a reduction. Just vocab, reminder of vocab. We've already talked about this before in dilations. Okay, if I want to find it, what the answer is, remember, scale factor equal, let's change the color, image over pre-image. Remember, we've talked about this before, and the easy way to remember this is I comes before P in the alphabet, so you know which one's on top. Okay, image over pre-image. Remember, we know it's image because it's got the hash marks here. Pre-image does not have the hash marks. Okay, remember, pre-image is the starting one, image is the ending one. All right, so this image length is greater than the pre-image, so it's going to be greater than 1, so it's an enlargement. If I want to get the actual number, one of two ways. I either calculate the distance exactly of, oops, of those two lengths and do the image length or the pre-image length, or I can go from, let's see here, from the center of dilation out to the pre-image point and the image point, and then divide those distances. And of course, it'd be the image length divided by the pre-image length. Okay, so it's your choice. Okay, sometimes they give you information, sometimes one's on a horizontal and a vertical, so it's easier to calculate. Okay, but it's your choice which one of those two you want to do. Since both of these are oblique, okay, it really doesn't matter. You have to do oblique, so you're going to use Pythagorean theorem on both of these. Okay, so it doesn't matter if I want to use this, for example, that triangle. I got 1, 2, 3, 1, 2, 3. So we know from that's a isosceles right triangle. So you know it's a 45, 45, 90 special right triangle. So the hypotenuse is 3 root 2. Remember, you got A, and A root 2. The hypotenuse is root 2 times longer. Here we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's another isosceles triangle. So that makes this one 6 root 2. Okay, 45, 45, 90, isosceles right triangle. Automatically, see an isosceles triangle, your base angle is congruent. Base angle is congruent, so that makes it 45, 45, 90. I do the image, 6 root 2, divided by the pre-image, 3 root 2. The root 2's cancel, 6 divided by 3 is 2. So scale factor is 2 in this case. Okay. Now, other words for scale factor. Scale factor is degree 1. Okay, that's dealing with degree 1. Okay, what other things are degree 1? Well, another thing that's degree 1 is perimeter. Okay, so if they gave you the perimeters of both of them, then I could just take the image perimeter divided by the pre-image perimeter, and that's the same as the scale factor. So perimeter is another one, or just the straight side length itself. Okay, if they told you one side length, pre-image side length was this length, image side length was this length, I just divide image length divided by pre-image length, and that's the scale factor. All those are degree 1. Okay. Oops, degree 1. Okay. If they were to give you area, which we'll be dealing with later on, but if they were to give you area, that's degree 2, you'd have to take the square root of both those areas, get down to degree 1, and then divide the image area, the square root of that is, divided by the pre-image area, the square root of it. Okay, and then that would give you a scale factor. That'll be something we'll do later. Okay, so just so you know that. All right, now let's talk about equations of lines. Let's say they give me this equation, 2y equals 4x minus 6. Okay, we want a scale factor, a dilation of 3 centered at the origin. Okay, it's always easiest when it's centered at the origin. Okay, so you got to pay attention. You're reading the word centered at the origin on the dilation. First thing I do is I got to solve for y always, put in slope-intercept form. So y equals 2x minus 3. Okay, once I do that, since it's centered at the origin, all dilations, remember, keep that property of parallelism. Not only are there side lengths, if there's multiple segments, they are parallel to each other. So just as we saw up here, okay, these two black segments, AB and A prime, B prime are parallel. So parallelism is kept. Also, if we were having a triangle, angle measure is kept. And then the side lengths are proportional. So remember we talked about the two P's, parallel and proportional for all dilations. and an angle measure is always congruent. So this is parallel. Remember, parallel means same slope. Okay. And where do you think all this is located? On your DCAS sheet. Okay, so parallel, same slope. So that means this 2 is not going to change. Remember, that's my slope right there. Parallel means same slope, so that's going to stay the same. All I have to do is multiply the y-intercept by that dilation. So y prime's line now is 2x, negative 3 times positive 3 is negative 9. And there's my answer. Okay, that's simple. Slope does not change. You just multiply the y-intercept, but you first must solve it and put it in a slope-intercept form. Okay, now let's say it's not at the origin. Okay, some of you might get an equation on the GCAS where it's centered at the origin. Some might get it where it's not at the origin. So you have to know how to do both. Okay, so let's say let me draw in coordinates here. Okay, x-axis, y-axis. Let's say we have this line right here. Okay. Sure it goes through there. Okay. What's the equation of this line? Well, I should easily be able to figure that out. I see my y-intercept is positive 1. The slope is up 1, right 1. So the equation of that line is y equals x plus 1. Okay. Well, let's say it says dilation factor of 2 centered at 0, 3. So 0, 3 is right here. We'll change the color. Got to know how to plot points correctly, so you have to know where 0, 3 is. And we want a dilation of 2 from there. Now remember, it's going to remain parallel because all dilations are always remain parallel. So that line will stay parallel. So what I do is I count how far it goes from here to that point right there. How far is that? 2. So every time I go 2, that's 1 dilation. So I want a dilation of 2, so I have to go 2 more. 1, 2. That's my second. It's a dilation of 2. Because that distance is 2, and obviously the total distance would be 4, right? 2 times 2 is 4, so that total distance is 4. So now I would have this line right here. Okay, it's parallel to it, but what's the equation of that line? That line now is, remember, it's going to be parallel, so it's not going to change the slope. It's still 1x. Now the y-intercept is negative 1. Okay, and this now would be my answer. Y equals x minus 1. Okay, so I can't just always multiply the dilation by the y-intercept because that would give me a positive 2 because it wasn't centered at the origin. That only works when it's centered at the origin. Here it's centered at 0, 3. So I plot 0, 3, count. Now, let's say it was centered at, let's say, negative 2, 1. Centered at negative 2, 1. So here's negative 2, 1 right there. We'll change the color. Again, it's centered at negative 2, 1. Okay. Again, I could, as long as I do the same thing, I'm good to go. Okay. So I could count down, or this is my original right here. I can count down, there's 2 there. And so I would need to go 2 more. 1, 2. There's a dilation of 2. Okay. And so there's that line again. That would happen to be the same line. Okay. I could have got a diagonal. It takes me 1 diagonal to get there. So I have to go another diagonal for a dilation of 2. Or I could have gone horizontal. That is a total of 2. So I must go 2 more for a total of 2. Okay. And all those points are on that line. Okay. Remember the line remains parallel. Okay. So anyway, that's how you can count if it's not like right on the x or y axis. You just count how many it takes you to use slope and count that distance till it hits the pre-image line and do that same amount. If it was 3, I'd have to go 2, 4, 6. Okay, and draw my line. Okay, let's see what else. So remember, if it's a triangle, the side lengths are proportional. So if they're dilated by a factor of 3, then the image is going to be 3 times as long as its pre-image corresponding side. So if the corresponding side of the pre-image was 2, and I did a scale factor of 3, the image length would now be 6. Remember, it's going to remain parallel. It's going to be a total length of 6, though. Okay, so just know that if you're talking about triangles. If I have a dilation of -2, remember that negative means it would go through the center of dilation to the other side. And say it was a point of 7, -1. All I have to do is take that dilation and multiply by both the x and y coordinates, and there's my answer. So it's going to be -14, 2 would be my answer if I'm dilating 7, -1. That means through the origin. Whenever it's written like this, the center of dilation is always the origin, just so you know. Okay, unless I told you otherwise, it's centered somewhere else. Okay. Let's see, what else? So you got some reflections and dilations put together on this sheet. Okay, so you're practicing your rotations and reflections from earlier transformations. More practice with that. All right, last thing would be perimeter to area. I sort of talked about this again earlier. Okay, let's say perimeter of pre-image is 10 and area is 9. What is the new perimeter and area under dilation of free? Okay, remember capital D sub 3 means dilation of 3, scale factor 3. Well, remember perimeter, PR for perimeter, that's degree 1. So when it's degree 1, all I do is take that answer, 10, and multiply it by that scale factor 3. So the new perimeter, or the pre-image perimeter, new perimeter equals 30. Okay, new area though. Okay, area is squared. Okay, so I'm squaring 3. 3 squared is 9 times. So it's going to be 9 times bigger. 9 times bigger than its original area. The original area was 9. So the new area is 81. Okay. If it asked about the new volume, volume would be cubed. It would be 3 cubed, would be 27 times 9. Okay. So just know that. Remember, perimeter is degree 1. That's why I wrote it down before. Area is degree 2. So I multiply the scale factor. Take that scale factor and raise it to that power. So this is 3 to the first, which is still 3. So that's why it's just 3 times 10. This is area, so 3 squared, 9. And if it was volume, it'd be 3 cubed, which is 27. And 27 times 9 would be the answer for the new volume. If the volume was 9 to begin with. You know, like say if they said the volume was 10, then it'd be 27 times 10, 270. Okay, so that's the last piece you need to know on anything from this worksheet. Everything else should be reviewed. Again, like I said, you're going to review with rotations or reflections as well. So you're going to add in that dilation. Okay, remember scale. So if I say dilation of 2 following a rotation of 90 degrees of 0.1 -4. We'll do one example of that. So remember, when it's function rotation, I go right to left. So I have to do the rotation of 90 first on that point, and then I dilate that by 2. Remember, that always means center of the origin. So rotation of 90, remember, reflect that over the x-axis first, which is the y coordinate. So we have x, -y. and then over the line y equals x, which makes it negative y comma x. So what is negative y comma x of that point? That would be 4 comma 1. And now dilation 2 just means to multiply each of these by 2. So my final answer is 8, 2. Okay. And so you'll have several of those to practice with dilations, reflections, and rotations. So you get to work on that as well. All right, that'll end this video, 20 minutes.